All right, so we're in the last section of chapter 2, which is going to be just interpreting graphs and talking about different graphs kind of outside the scope of the class just a little bit. So, for example, we're going to be talking about multiple graphs or multiple bar graphs and then multiple line graphs. So what this allows us to do is compare information very quickly between multiple categories or causes. So here we have men in this dark brown and we have women in the tan. And what we want to do is we want to compare the incomes between the various degrees first. So if we look, we can see that as your degree increases, so does your wage. So more education means more money. Okay? Now when we look at the comparison between the two genders, what we can see is that in every category, very quickly, that men are going to be earning more money. So we were able to deduce all that information super quick just by looking at the stacked graph, and we didn't have to look at multiple ones, so the stacked bar chart. Now, if we look at this stacked plot, which is looking at the total amount it costs to go to a college, okay, we're going to be looking at between public 2-year commuter colleges, which would be like Olympic College, all the way up to private nonprofit 4-year campuses. So, obviously, we can see right off the bat that the longer you go to school, the more expensive it's going to be. As well, we can compare each category very quickly. So, which category varies the most between the colleges? Well, right off the bat, I can see that it would be tuition. Okay. However, where they vary the least would be books, other expenses, and it looks like transportation. Okay, room and board, it's kind of in the middle. I mean, the difference between 7,000 and 10,000 is pretty big. Um, but yeah, so we were able to get this information really quick. Same thing here where we have a stacked line graph. What we're looking at is the death rates per 100,000 between 1900 to 2010. And we're looking at 4 key diseases. So we're looking at pneumonia, cardiovascular, which means your heart, tuberculosis, which is a lung disease, also called consumption, and cancer. So first off, the amount of deaths per 1,000 between 1900 to 2010 has decreased significantly. Okay, now we want to know where's the most progress been made. So if we look here, we had quite a few people dying from tuberculosis in 1900, but almost nobody from 1960 on. We can also see that there's been a lot of progress made with pneumonia. So we can see that pneumonia was very wide here and then gets very small here. So the most progress has been made with tuberculosis, which is called TB, and pneumonia. Now, even though I didn't ask these questions here before, there's something interesting that's happened here. And even though I see that the amount of deaths caused by pneumonia and TB have gone down, what I can see is the amount of deaths for cancer has gone up. So this leads us to asking maybe more research questions, which is like, cancer, what up? So go ahead and just take a minute and think, why did cancer increase? So here's what a couple of my students and I have come up with in the past. Maybe cancer has increased because we can detect it easier. So a lot of the times people would die from something that they thought was pneumonia or tuberculosis, but in reality was actually lung cancer. Okay? Another reason is that people are living longer. And we have more exposure to a lot of different things. The other area that looks like it's kind of gotten worse and then maybe got a little bit better is cardiovascular. Think of some reasons why you think it got really bad in the 1960s and then improved. All right, the next example is just kind of for fun. So we've all seen a weather map, but you probably didn't think that it was um, an example of a graph, but it is, and it uses two different techniques to give the reader information. Not only does it use numbers, it also uses colors. Okay, so that's still information in a graph. Now, 3D graphs have become more popular as technology has increased. So if we look at this one, we're looking at CO2 emissions, which you could kind of construe as pollution, the year, and the country. So we're able to look at 3 variables at once instead of just 2. So if we look at this, there's a couple of things that maybe we would find interesting. Is that China has increased the most. Okay. The other one is that it looks like Japan has stayed pretty steady. But what I find to be the most interesting is actually Russia, because if we look at Russia, it went down and then back up. So my question is, Russia, what happened between 1995 to 2005? Which is not a question that we have to leave unanswered. We could easily look this up on Google, and maybe there's some historical information that happened in Russia's government that caused a lot of people to leave, and then CO2 emissions went down. So we get more information when we have 3D graphs because it allows us to look at more than 2 variables. Okay. I love infographics. These are also called word maps. And you can make these on StatCrunch if you go under graphs. So what they do is that they look at all the words from a certain piece of text, and they leave out filler words like the, a, and, things like that. And then they show you, using size, the ones that are the largest. So this is one of my favorite examples because I always get strung up for this one. I've never read Harry Potter, so when I look at this, I think, oh, it's a book about a Mrs. Professor Dursley who has a cat. I see the word eyes and owls and suddenly and left and sign, and I just think that it's about a detective. When other people have told me about this book, they tell me, oh, he lives with his awful family members named Dursley, and Harry Potter's the main character, and they tell me what happened. I'm like, oh, all of these words make a lot more sense. So what else do you need to know to understand? Well, the big answer in this class is context. You need context to know what things mean. Okay. So, the last thing we're going to talk about is a couple of cautions. So the first one is perceptual distortion. So, both of these images are trying to display the same information to the reader, but our perception is going to be off. So what it's talking about is that revenue has doubled between 1984 to 2010. However, if somebody looks at the picture to the left, they would actually think it's done more than doubled. Maybe they think it's tripled or quadrupled, and here's why. Is because if we look at the length of the plane is twice as long in both pictures. However, our brains don't look at just length, they also look at area. So, instead of thinking it's 2 times, we think it's 4 times bigger. However, if we look at the bar graph, not only is it twice as tall, it also has twice the area. So we get a more honest representation of the data. As well, we have to keep an eye on vertical scales and where do they start. So here, this one starts at 30, this one starts at 0, and they look very different. So the one on the left shows a lot more extremes, whereas the one on the right shows that each of these vehicles actually gets a more similar gas mileage than you might think. Now, both of them have advantages and disadvantages. The one on the left is a little bit easier to see the exact amounts. So for example, I can see that this car gets 36, 34, and 31 miles per gallon. Whereas if I was looking at this one, I wouldn't be exactly sure. However, again, when we're talking about perception and perceptual distortion, if I just looked at the left-hand one and I didn't pay attention to the axes, I would think, oh, Toyota gets maybe a sixth of the gas mileage or a fifth of the gas mileage as the Honda, right? Just because I can fit a lot more of the Toyotas inside the Honda bar. Whereas when we look over here, that's just not true. Now, when we look at this one, we want to know what is the issue with this graph here, or this visual aid. And the reason that this is maybe not an honest portrayal of information is because our scale goes from 1804 to 1927, which is a difference of 123 years. However, when we get towards the end, we only have a difference of 16 years. So what this information would actually look like if the x-axis was uniformly separated is it actually look more like a hockey stick and less like a straight line. The other thing is that they're talking about the world population in billions of people, and they're trying to display, one, that maybe it's not growing as quickly as it actually is, and two, the visual aid in the background is trying to give you this like kumbaya, everything's okay feeling, when really our population is increasing at a staggering rate, and like maybe we should be worried. So, to summarize this section, you should always keep an eye on the numbers that are being displayed both on the x-axis and the y-axis and look out for perceptual distortion.